Right, we're going to take a look at the latitude questions here. The first one has to do with looking at the star chart. It says the time exposure photograph shown below is taken by an observer in the northern hemisphere to record the apparent paths of stars. What you notice is one star in here is not moving. All the other stars are moving around, and the name of the bright star near the center would be Polaris. It would be A. Let's move on to the next question. Which statement best explains why stars are viewed from the northern hemisphere appear to revolve around Polaris? So the stars are appearing to revolve around Polaris, not because they're moving, but because the Earth rotates on its axis. The angle of the star Polaris above the northern horizon can be used to determine an observer's. We use Polaris to determine an observer's latitude. Base your answers to the following questions on the diagram below and on your knowledge of Earth science. The diagram represents the lines of latitude and longitude on the Earth. Points A through E represent locations on the Earth. And which location would an observer never see Polaris in the nighttime sky? There would be choice D here, but if there was another choice for E, it would also be E as well. They're both located in the southern hemisphere where you can't see Polaris. Okay, base your answers to the following questions on the world map below. Letters A through D represent locations on the Earth's surface. At which location could an observer not see Polaris in the nighttime sky? The answer would be B, because it's in the southern hemisphere. Number 6, the diagram below shows an instrument made from a drinking straw, protractor, string, and rock. What I notice here is it's got this weight to measure an angle. You look through here to a star. The instrument was most likely used to measure the altitude of a star, and that would possibly give you the latitude. The diagram below shows an observer on Earth viewing the star Polaris. The altitude above the horizon is 52 degrees. Since they can see Polaris, they must be in the northern hemisphere, and their angle is equal to their latitude, so letter C would be correct. Number 8, the diagram below shows an observer measuring the altitude of Polaris. They're tilting their scope above the horizon 20 degrees upward, so their latitude would be 20 degrees north latitude. In this diagram, the diagram below shows an observer on Earth measuring the altitude of Polaris. You see the measurement from the horizon, also from the zenith. What is the latitude of the observer? It would be 43 degrees north. We use the angle of Polaris above the horizon to find our latitude. In this diagram, the diagram below shows an observer on Earth measuring the altitude of Polaris. We have a 66.5 from the horizon, or 23.5 from the zenith down. What is the latitude of the observer? Automatically, we're going to go with the number that we have between the horizon and Polaris is 66.5 degrees north. Number 11, the diagram below represents an observer measuring the altitude of Polaris. We see 53 degrees above the horizon, or 37 degrees below the zenith. We always use the horizon number, so our answer here would be letter C, 53 degrees north. The diagram below shows the angular altitude of Polaris above the horizon at a certain location. So what we'll notice here is that we have 90 degrees, and each one of these boxes here, if I count them, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Each one of these is going to represent 10 degrees, since 90 divided by 9 gives me 10. So being that this line is the site of Polaris, that would be 10, 20, 25 degrees of an angle, 25 degrees north latitude, letter B. The diagram below shows the altitude of Polaris above the horizon at a certain location. What is the latitude of the observer? Well, once again, we see this chopped up into 9 boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each box worth 10 degrees, so that'd be 10, 20, 30, 40 degrees north. Which graph best represents the altitude of Polaris observed at a northern latitude position on Earth's surface? As our latitude increases, the angle of Polaris increases. Letter B is the correct choice. Here we see different diagrams. It says which statement about Polaris is best illustrated by the diagram shown below. At the equator, Polaris is at the horizon. When we get to New Orleans, Louisiana, Polaris is at 30. When we get to the North Pole, Polaris is at 90. Now, the reason for this is that Polaris's altitude is equal to a location's latitude, letter D. On April 21st, the altitude of Polaris, as viewed from a location in New York State, was measured at 41.3 degrees. What will be the altitude of Polaris when viewed 1 month later on May 21st at the same location? It will still be 41.3 degrees. The angle of Polaris doesn't change unless you change your latitude. 17. The dashed line on the map below shows a ship's route from Long Island, New York to Florida. As the ship travels south, the star Polaris appears lower in the northern sky each night. Now, the best explanation for this observation is that Polaris is located directly over the North Pole, and so its position doesn't change unless you change your latitude. An observer on a moving ship notices that the altitude Polaris increases each night. It's getting higher in the sky each night. Local solar noon occurs at the same time each day, which means they're staying on the same longitude line. So in which direction is the ship moving? Since it's increasing each night in altitude, Polaris is indicating that they're traveling north to higher latitudes. As a person travels due west across New York State, the altitude of Polaris will remain the same because you're not changing your latitude, you're staying on the same longitude line. As a person travels northward from the equator, the altitude of Polaris will appear to increase because their latitude's increasing. The diagram below represents the route of a ship traveling from New York City to Miami, Florida. Each night, a passenger on the ship observes Polaris. And which statement best describes the observed changes in the altitude of Polaris made by the passenger during the voyage? What they're going to notice is that Polaris is always going to be in the northern sky. That doesn't change. But since they're traveling south each night, the altitude is going to decrease. So letter A would be the right choice. At which latitude will Polaris be overhead? Well, overhead would be looking up at 90 degrees from the horizon. So it would be D, 90 degrees north. In 1641, the crew of the ship Concepcion used the sun and stars for navigation. The crew thought that the ship was just north of Puerto Rico, but ocean currents had carried them off course. The ship hit a coral reef and sank off the coast of the Dominican Republic. The X on the map marks the location of the sunken ship. So we're looking at part of the Caribbean here where we have longitude lines in this direction, latitude over here, and we see things like 12, 15, 18, 21, 24. So this must be the northern hemisphere here, and this must be the western hemisphere here. Well, in which map location does Polaris appear highest in the sky would be where we have the highest latitude, and that's going to be where Miami, Florida is, where the latitude would be at its highest. So letter A is the right choice. Next question. The lines on which set of views best represent the latitude system? So latitude lines appear from the equatorial view, looking at the globe from the side, to go across as parallel lines. But looking from the poles, these lines become circles, so letter B would be the best choice. The data below the data table below shows the altitude of Polaris is recorded by 4 observers at Earth's different locations. Which statement is best supported by the data table? What we see is B and D found the same altitude of Polaris, so B and D must be, or B and C rather, must measure the altitude at the same latitude. So letter C is correct for that. Number 26, base your answer on the following questions on the map, which shows the latitude and longitude of 5 observers, A, B, C, D, and E on Earth. And the question is, what is the altitude Polaris above the northern horizon for observer A? So since we are dealing with the altitude of Polaris, we're dealing with latitude. If they're 10 degrees north latitude, they're going to see Polaris at 10 degrees. Okay, on the star chart, circle the dot that represents Polaris. So since I would use the Big Dipper here, and the front 2 stars of the Big Dipper would lead me to Polaris, Polaris would be this star right in the center, right over here. Okay? And that's part of the Little Dipper, which pours into the Big Dipper. Identify the star located in the center of this map. So here is the Big Dipper once again. And here's the Little Dipper, and right on the very handle of the Little Dipper there is your star Polaris. Number 29, It says, base your answers to the following questions on the diagram in below and on your knowledge of Earth science. The diagram represents the star patterns of the Big Dipper and Little Dipper relative to Earth's horizon. So here's the flat surface of the Earth. Here's what you'd see if you were looking towards the north. You'd see the Big Dipper and the Little Dipper. And if you follow these stars right here, they lead you to Polaris. Now it says dashed vertical lines, reference lines are shown for the 4 stars of Polaris and Polaris's label. So on the diagram, place an X at the point on the horizon line to indicate due north. That would be directly below Polaris. So if I wanted to draw an X, I'd be looking at a spot right over here for my X, okay? And then this question says the group of stars known as the Big Dipper can be used to locate the North Star Polaris in the night sky. On the diagram of the Big Dipper provided, draw a straight arrow passing through the 2 stars to indicate the direction of Polaris. And if I use this tool here, that would be straight out like something like that. So you'd use those 2 stars right there. Okay, that concludes our work on latitude. Let's get to longitude.